All right, so that was the introduction to the polynomials lesson. But the reason I was outside in my pajamas is because this week is Virtual Spirit Week, and Monday is Pajama Day when you'll see this, and Tuesday is Go Outside Day. So I kind of covered both of those in one, since you will not have any specific lesson on Tuesday related, like that has notes or any video or anything. So, okay, so today we're going to do polynomials. So this is going to be on the 23rd, and so it's going to be polynomials. And then, oh, by the way, like my colorful rainbow nail polish for the for Spirit Week as well. Oh, that does not look focused. What did you do to this? It's not, you played with it and it's not a focus one. Okay, so it's going to be polynomials combining like terms. Why did you play with it? There you go. And multiplying polynomials, or at least some polynomials. Okay, so that's what we're going to be looking at. So first of all, so what is a polynomial? So a polynomial is an algebraic expression. This is kind of a long definition. That is the sum of terms where each term contains only variables with positive exponents and integer coefficients. Okay, so that's a really long way to say these are types of polynomials. So things like 5x plus 3 is a polynomial. Okay, and 4x squared plus 10x plus 9 is a polynomial. Okay, also 5xy plus 3x squared plus 8xy squared plus 10 is also a polynomial. Okay, technically even 5 is a polynomial. Okay, so and a term is each component of the polynomial. So for example, so for the 5xy plus 3x squared plus 8xy squared plus 10, the terms are 5xy and 3x squared and 8xy squared and 10. So whoops, sorry about that. And then so just the different ones that are there. Okay. So then there are some specific types of polynomials. I'm going to turn the page because I'm going to run out of room here. So for example, so there's a monomial. Okay, and a monomial is just basically a polynomial with just one term. Okay, so something like 5x or 8, okay, or 19, y. Okay, so those are all monomials. So then a binomial is a polynomial with two terms. Okay, so for example, 5x plus 2 or 8x squared plus 12y or something like that. Okay, and then the third one we actually will mention, and then we really kind of don't bother with anything beyond this for the most part. We just start calling them polynomials. A trinomial is a polynomial with 3 terms. So something like 8x squared plus 5x plus 4. Okay, or 8xy plus 3y squared plus 9x. Okay, those are all trinomials. Okay. All right. So, and then one more thing to mention about polynomials is the degree of a polynomial. Okay, so the degree of a polynomial. I'm sorry, so first of all, the degree of each term in the polynomial. Start with that. The degree of each term in the polynomial is the sum of the exponents in that term. So, for example, if we take something like 5xy plus 3x squared plus 8xy squared and then plus 10, okay, so this degree would be that x is to the first and the y is to the first, so it would be 1 plus 1, which is 2. This obviously would just be 2 because it only has one variable there. And so this one would be that's x to the first and y squared, so the degree would be that 1 plus 2, so the degree would be 3. And if there's no variable, then the degree is 0. Okay? And so then the degree of the entire polynomial is the highest degree of the terms it contains. Terms it contains. Okay. So, for example, if you have something like this, x squared plus 2x plus 7, this is degree 2, this is degree 1, and this is degree 0, so the polynomial degree is 2, because they take the highest one. Okay, if you take something like this, which is a little bit more tricky, but not too bad, degree here is that 2 plus 5, which is 7. Here, it would be that 3 plus the 1 that's on the y right there, right, which that was 4. And this one, because there's only a 1 there, the degree is 1. So the polynomial degree here is 7. Okay, so that's degrees of polynomials. Okay, now we're going to look at combining like terms. I'm going to turn this because otherwise I'm going to run out of paper on that page. Okay, so combining like terms in a polynomial, and we've done this in the past with some types, but not quite as to the high degree. So like terms in a polynomial, they're going to be terms that have sorry, that's my dog, the same variables to the same power. So same variables to the same power. Then if that's true, then they can be combined. When you're adding or subtracting. Okay? So, for example, so let's say we have something like this, 4x squared y plus 2xy plus 3x squared plus 5x plus 10x y, minus 5x squared. Okay, so what can we combine here? Well, the 4x squared y stays as is because it doesn't get combined with anything. So, but we can combine this 2xy and that 10xy, giving me 12xy. Okay, and then we can combine the 3x squared minus the 5x squared. Okay, and that 3 minus 5 is -2, so -2x squared. And the other two things, there's nothing else. There's no other 4xy, so we just kind of add that in. So 4x squared y, and the 5x also is kind of by itself, so plus 5x. Okay, and it doesn't matter what order that's in. So then here's an example of one where we might not be able to add quite as many things. So if I had something like this, where I have 3x plus 4 plus 10y minus 8. So the only like terms I have here are this 4 and the -8. So I just write 3x plus 10y again, and then 4 minus 8 is -4. Okay, again, doesn't matter what order it's in, but I can combine that, and that would be the final way I could write it. So one more example of combining like terms in a polynomial. So something like 3x squared plus 10x plus 8x minus 9 plus 5x squared. So what can I combine here? And on this one, I can combine my two x squared terms. So the 3x squared and the 5x squared gives me 8x squared. I can also combine the 10x and the 8x, giving me 18x. Okay, and then I can also, I can't combine the 9 with anything, but I can write that 9. So then my simplified version would be that. So 8x squared plus 18x minus 9. Okay, now I could also use algebra tiles to do this. The algebra tiles are just a way to show certain types of, certain variables and certain powers. So algebra tiles, if you want to use them, so this represents an x squared, and a bar like that represents an x, and then each individual is a 1 like that. So for example, I could add some x squareds, some x's, okay, and then some 1s, and then along with maybe another one. So, and then an x, and then a 1. So because these are all the x squareds, I have 1, 2, 3, 4, 5. So this would be 5x squared total. And then I have 1, 2, 3 of the x's, so that'd be 3x. And then 1, 2, 3 of the individuals, so that'd be plus 3. Okay. So normally you will have you'd have the x squareds and all those things written in there. X like that. Okay. So either way, that's how you would write that out. Algebra tiles are mainly used for x squareds and x's and just individual things. Okay, so last thing we're going to do here is multiplying polynomials. Okay, and there are many methods to do this. Well, first of all, we'll start with relatively simple ones, a monomial times a binomial. And you've already done this before. It's basically just distributive property. In fact, it is the distributive property. Okay, so it's just going to be the distributive property. So for example, if you did something like 3x times 2x plus 4, you would just multiply the 3x times the 2x and the 3x times the 4, giving you 6x squared plus 12x. Okay, and another example, if something was already being squared or something like that. So hang on just a sec. Okay, so if you had something like 8x squared times 3x minus 7, then you would just multiply those. 8 times 3 is, of course, 24. X squared times x to the first, as you know, is x to the third. And then 8x squared, that times that 7. So 8 times 7 is 56. And since there's no x here, it's just 56x squared, like that. So all you're doing really is the distributive property there. And if we were to do now a monomial times a polynomial times maybe a longer one, it's still distributive property. You're still going to be distributing things. So you might, for example, do something like 5x times 2x squared minus 7x plus 4, and then you would just multiply through. 5 times 2 is 10. X times x squared is x to the third power. And then 5x times that negative 7x, 5 times negative 7, is going to be negative 35. And then x times x is going to be x squared. Okay, and then the third one you would do is you would do that 5x times the 4, so plus 5 times 4 being 20. And then x times, with no x in it, just 20x, like that. Okay, let's do one more. Let's see if we can fit it, if I can fit it down here. So if I do, let's say 8x squared times negative 5x squared plus 9x minus 7, okay, and then you could do the 8x squared times the negative 5x squared. 8 times negative 5 is negative 40, and x squared times x squared is x to the fourth, okay, and then 8 times that 8x squared times that 9x, 8 times 9 is 72, x squared times x is x to the third, and then the last one would be that 8x squared times that negative 7, would be minus 56, and in this case x squared. Okay, so that's how you multiply monomials and polynomials, and monomials and binomials. Now, the last thing we're going to do is what's called multiplying. Well, it's multiplying two binomials. Okay. Now, there's a couple ways to do this. You can use algebra tiles. Okay. And basically, what you do when you use an algebra tile is you'll write the two things. So let's say I want to do x plus 5 times x plus 3. Okay. So I would write, on one side, I would write basically an x and a 5. Okay, and then on the other side, I would write kind of an x and a 3. Okay, and what happens here is, of course, you get the x times that x is that x squared. Okay, and here you'll have 5 x's, because 5 times x gives you 5x. Okay. And then down here, and what that would be written as is you'd have these 5 boxes of x's, basically, okay? And then here you would have 3 x's, because here I had x, so I had 1, 2, 3 x's, which is 3x. Okay, and then 3 times 5, I would have 15 little boxes here, but I'm not going to write those all out. So in the end, you would have x squared plus 5x plus 3x plus 15, okay? Then you could combine these middle terms, and you'd have x squared plus 8x plus 15. Okay? So I'll show another one with algebra tiles, and then we can kind of do one with a different method, which you won't have to use algebra tiles if that's not helpful to you. I don't find algebra tiles particularly helpful to me. But let's say I had something like this. So I had 2x plus 3 and x plus 4. And I'll try to do this one where they're different colors so it's a little bit easier to see. So I have 2x, so I have an x and another x. And then I have 3, so I'll go 1, 2, 3. So there's my 3. Okay, and then here I have an x. So over here I have an x. So that's about the same distance as those. And then I have 4. Okay. So you can see kind of the x by x would be x squared. And this other x by x would also be x squared. Whoops, sorry. X squared. That's what I meant. Okay, and then this 3 here would be 3 times x. So you'd basically have those 3 boxes like that. And that would be 3x. I don't normally write the boxes. Okay, here I would have 4 of those boxes. Not exactly to scale here. So 1, 2, 3, 4 there. And I'd have 4x. Okay, I'd have another 4x here. And then here I would have that 3 times 4, I would have 12 there. Okay, so in the end, if I add them all up, I have x squared plus another x squared plus 3x plus 4x plus 4x and then plus 12. Okay, whoops, sorry. Okay, so all of those, when I add that up, I have, in this case, 2x squared. And then if I add up the 3x, the 4x, and the 4x, that's 8x, 11x. Okay, and then the last term, which is that plus 12 at the end. Okay, so that would be the final answer when I multiply those two things out. Now, there is another way to do these, and I'm going to use the same examples. So we're going to end up with the same answers. Well, I'm going to use those two examples plus another one, actually. Okay, but this method is something called the FOIL method. Okay, so as I turn that over. Okay, this is called the FOIL method. I'm going to use some of the same examples on this one. Okay, and this is again multiplying binomials. Okay, and this just means that you don't have to use algebra tiles. Okay, so the FOIL method stands for first, outer, and inner, and last, or sometimes they say outside, inside. Okay, so for example, if I were going to do the one we just did, the 2x plus 3, and then times x plus 4, for example. Okay, so what I'm going to do first is I'm going to multiply the first two terms. So this is the first two terms, 2x times the x. Okay, so the first, and I'm going to kind of write it here up top so you can kind of see it. First, 2x times x would be 2x squared, okay? Then I'm going to multiply the outer terms, so the outside here and the one on the outside, the way outside on both edges. So the outer here and the outer here, that's that 2x plus 4. So that's the outer, or 2x times the 4. 2x times 4 is 8x, okay? Then I'm going to multiply the inner two terms, so I would multiply, oh, I should mark that as outer. Okay, so that's outer. Okay, then I'm going to multiply the inner two terms. So these two, those are the inner two terms. 3 times x, which is 3x. And then the final thing I'm going to do is multiply the last two terms. So these two are the last two terms. Okay, so this was inner. And this was the last one. And the last is 3 times 4, which is 12. Okay. So, but again, you'll notice that just like before, like that last one, if I add these two up, I get 2x squared plus 11x plus 12. Okay. When I do the whole thing out. Okay, so I'm going to do a couple more examples of this, and then we will be done with the note idea. Okay, so let's try another example of the FOIL method. And again, first, outer, inner, last. We're not going to write it that way every time. But let's, for example, do x plus 9 times x minus 1. Okay, so now we're going to do the first two terms. And I'm going to, again, write it as first over here. So, and first over here. So that's that x squared. Okay, and then again, this time I'm going to still write it as the outer two terms. So x times a negative 1, so minus 1x, which was my outer two terms. Okay, then my inner two terms, so the ones on the inside, the inner two terms, which is 9 times x, which is plus 9x, which is my inner two terms. And then the final one would be the last two terms, which would be that 9 times the 1, so the last, 9 times the negative 1, excuse me, minus 9, is my last. Okay, and then I'm just going to combine the like terms that I can, which is negative 1x and 9x. So I get x squared plus 8x plus minus 9. Okay, so there's my answer when I multiply x plus 9 and x minus 1. Again, you could use algebra tiles for these. When you use algebra tiles with negatives, you just darken them in. For some people, that helps a lot. Okay, the last example I'm going to do is going to be one that kind of does something slightly different, but it's the same method. Okay, so I'm going to do 2x plus 4 times 2x minus 4. Okay, so on this one, I'm going to do again the first. So on the first, it's 2x times 2x, which is 4x squared. Okay, and then I'm going to do the outer, 2x times a negative 4. Okay, so which would be minus 8x. Okay, then I'm going to do the inner, which would be that 2x times a positive 4 now. So inner would be the 2x times the 12, it's plus 8x. And then the very last two terms, which would be that 4 times that negative 4, so minus 16 there. Okay. Now in this case, though, and this is why it was kind of a special case, when these two in the middle, negative 8x and positive 8x is nothing. So you end up actually with those two canceling out, and you just get 4x squared minus 16. All right, that is the end of all of the notes for this lesson. I know it was kind of a long set of notes. I hope everyone is doing well, miss you all, and hope that your time at home is not too boring and that you're getting some time to enjoy family and things like that. All right, thanks.